This section is for 1.1, which deals with linear equations. Here are the steps for solving linear equations. First, list any restrictions on the domain of the variable. Well, what is the domain? The domain is the set of all possible values that variable can be. To find the domain, start with the set of all real numbers, then exclude any numbers that might make the denominator equal to 0. After you found the domain, I would suggest to clear fractions by multiplying both sides by the least common multiple of denominators. Then simplify each side of the equation by distributing to eliminate parentheses and combining like terms. Then collect all terms containing the variable on one side and all other terms on the other. Then simplify and solve. Always don't forget to check your solution with the domain. If once you found your solution up here in step 6, once you check it, if it doesn't work in the domain, then it actually is not a solution. We'll go through an example of this. The first question that's here is asking us to find the domain and then solve the equation. In order to find the domain, you always start with all possible real numbers. Then you look for any exclusions. Things that would be excluded from a domain would be things that make your calculator give you a potential error. Let me give you 2 examples. So an example of an error you would get on a calculator is if you were to try to divide something by 0. If you put this into your calculator, you will get an error message because this is undefined. You cannot divide something by 0. So if I put x on the bottom, I would say x can be any real number except 0. X can never be 0 because it makes the denominator 0. If I put something like 2 over x minus 5, I would say x cannot be whatever makes this whole thing equal to 0. So in this case, if x minus 5 cannot be 0, and I add 5 to both sides, that means x cannot be 5. Obviously, if I take 5 and I plug it in here, that's going to make the denominator 0. So my domain would be x cannot equal 5. So again, anything that makes the denominator 0 would be excluded from the domain. Another thing that makes denominators, makes your domain undefinable is when you have negative under even root symbols. So for example, I cannot take the square root of negative, well, let's make it 4. I cannot take the square root of negative 4. There is no number times itself that will ever give me negative 4. This is also undefined. So any number that is negative underneath a root symbol that is even will always give you an undefined or error in your calculator. Therefore, if I put an x underneath a square root, my domain, I would say x has to be positive or 0. So x has to be anything that is greater than or equal to 0. If I put anything negative in here, I will get that error message. So those are the 2 things you should be looking for. Even roots, which cannot be negative, and also denominators, which cannot be 0. So those will be the 2 things we'll be looking for when we're asked to find domain. So in this first question, part A, it's asking me to first find the domain and then solve. Okay? There are no denominators, there are no root symbols. So my first instinct is to say that the domain is going to be all real numbers. There are no exclusions. X can be anything. So let's go ahead and solve. The first step says to clear fractions. We don't have any fractions, so there's nothing to do for that step. The next step says simplify by distributing and eliminating parentheses, and then combine like terms. So let's get rid of these parentheses by distributing that subtraction sign up front. So this becomes 2x minus 3x minus 3 equals 2x minus 18. And then combine like terms. 2x minus 3x is negative x minus 3 equals 2x minus 18. Our next step is to collect all terms containing the variable on one side of the equation and then all the other terms on the other side. So I'm going to choose to put my x's on the left-hand side, but you can put them on the right if you prefer. So I'm going to subtract the 2x and move it over to the left side. So that gives me negative 3x minus 3 equals negative 18. Then I'm going to put the constants over to the right side. So that gives me negative 3x equals negative 15. Once I divide by negative 3, you can see x equals 5. But always make sure you check your solution. Two things you should do. You should always check your solution in the original, just make sure it works. Let's do that. 2 times 5 minus 3 times 5 plus 3, is that in fact equal to 2 times 5 minus 18? 10 minus 15 plus 3 is equal to 10 minus 18. 10 minus 18 equals 10 minus 18. In other words, negative 8 equals negative 8. So yes, it in fact does check. Another thing you want to do is make sure that this is in your domain. Is 5 in the domain of all real numbers? Of course, 5 is a real number, so that means this is the only solution. Looking at the last one, again, we don't have any restrictions because there is no denominator, there are no square roots, so my domain is going to be all real numbers. X can be anything. There are no exclusions. Next thing we do is clear any fractions, but I don't have any, so then I'll get rid of parentheses. So let's distribute to get rid of parentheses, which gives me 2x squared minus 5x. Over here, this becomes a FOIL problem. So let's FOIL. 2x times x, 2x times negative 3, 2 times x, 2 times negative 3. Then we're going to simplify by collecting like terms. You can see that those are alike on the right-hand side. Then we're going to try to get all the x's to one side. So let's move this 2x squared to this side. Look what's going to happen. They're both going to cancel. I'm also going to move this 4x over to this side. So that gives me negative x equals negative 6. Last thing I want to do is divide out the coefficient. So let's divide out that negative 1 that's out in front. So that gives me x is 6. X definitely is in my domain, but let's also check to make sure it's the accurate solution. So we go up to the original and we put in 6 for x. So 6 times 2 times 6 minus 5 equals 2 times 6 plus 2, 6 minus 3. So this is 6 times 12 minus 5 equals, this is 12 plus 2, which is 14. 6 minus 3 is 3. So we have 6 times 7 equals 14 times 3. 6 times 7 is 42. 14 times 3 is 42. So it does check out. Next question. First, we find the domain. Are there any restrictions? Well, I do see denominators, but there are no x's in the denominator. So there is no way to ever get a 0 in the denominator. There's a 2 and a 3, but there are no variables. So since there are no x's in the denominator, my domain is actually still all real numbers. Okay? So let's go ahead and simplify this equation. What I'm going to do first is I'm going to get rid of any fractions. I don't like these fractions here. They're difficult to deal with, so I'm going to eliminate them. The way we eliminate fractions is we multiply both sides of the equation by the lowest common denominator, which would be 6. So I'm going to multiply this whole side of the equation by 6, and I'm going to multiply this whole side of the equation by 6. When doing that, you'll see that this 6 is going to get distributed to both parts. So it becomes 6 times x plus 4 over 2 plus 6 times x plus 1 over 3 equals 10 times 6. When we do that, you'll see that the 6 will end up reducing the denominator. 6 over 2 is 3. 6 over 3 is 2. So what I have then is 3 times x plus 4. The denominator is now gone. Plus 2 times x plus 1 equals 60. So now this becomes a much easier equation to solve for because I don't have those denominators. So then we solve like we did the previous problem. First, distribute. 3x plus 12 plus 2x plus 2 equals 60. Collect like terms. Get x's to one side, and then move these constants to the other. Last step is to divide out the coefficient. So we have x equals 46 fifths. Now before I say for sure that that is my answer, of course I should do two things. You should check it in the original and also make sure it's in your domain. Well, it is in my domain, so I'm good there, but I am going to check it in the original. So I've got 46 fifths plus 4 divided by 2 plus 46 fifths plus 1 divided by 3. Is that in fact equal to 10? Well, sometimes these can be a little bit easier if you put them into your calculator. So that's what I'm going to do now. Okay, so in my calculator, let me put this question in here. I'm going to need some parentheses. So we've got 46 fifths plus 4, that's my numerator, divided by 2. Then we're going to add to that 46 fifths plus 1 divided by 3. And the hopes are when I hit equals that I'm going to get 10 as my answer. So it does check. So make sure you're always checking your answers so you know for sure that this is correct. Next one. To find the domain, we must look for denominators. We do have a denominator. This time we actually do have a variable in the denominator. So I will actually have a restriction. There will be something that I will exclude from all real numbers. This denominator cannot be 0. By adding 6 to both sides, that means x cannot be 6. Notice if I put 6 in there, I get 6 minus 6, which is 0. That makes the denominator 0. The same thing would be true for this one over here. Since it's the same, x cannot be 6. Now some of you might look at the top and say, well, maybe x can't be 0 either. But actually, it doesn't matter what's in the numerator. You can put 0 in the numerator and that is okay. That just means your answer is equal to 0. But you may not have 0 in the denominator. So in this case, x cannot be 6 because it makes the denominator 0. So my domain, I would say x cannot be 6. And when you say that, that implies x can be anything else as long as it's not 6. Okay, so now I'm going to solve this. That was for the domain. Now I'm going to solve this. The first thing like I said with the last question, what you should do is always get rid of the denominator. So I'm going to multiply both sides by that denominator. So I'm going to multiply this side by x minus 6. I'm going to multiply this side by x minus 6. So when I do that, I'm going to get x minus 6 times x over x minus 6. Now we're going to get plus x minus 6 times 1. And then we have 6 over x minus 6 times x minus 6. So you'll see that these are going to cancel. So my denominators are gone. So what's left is x plus x minus 6 equals 6. So this becomes a very simple linear equation to solve. So let's combine like terms. So we have 2x minus 6 equals 6. Get the constants to one side. Divide out the coefficient. And you have x equals 6. But wait. What did I just get done saying? In the domain, x cannot be 6. But in the solution, we said x is 6. So, when you find a solution, but it's not in your domain, then it's actually not a solution at all. Since there were no other solutions, that means there is no possible solution to this equation. Because if 6 was the only possible solution, but it made my denominator 0, that means there is no possible solution overall. So we would say either no solution, or you can say x is the empty set, meaning it's a set of solutions with nothing inside of it. Or you could even describe it as the curly brackets with nothing inside, meaning there's no solution. So there's a few different ways you can express that. All right, part E. In part E, you can see, first thing, for finding the domain, we look for denominators. In this case, we do have denominators, but there are no variables down there. Since we can never turn 7 and make it a 0, or make a 3 into a 0, that means x can be any real number. Okay, there are no restrictions. So what I'm going to do over here is I'm going to get rid of my parentheses. I'm going to multiply both sides by the least common denominator. In this case would be 21. When I distribute, I get 21 times x plus 2 over 7 equals 21 times 5 minus 21 times x plus 1 over 3. You'll see that this 21 and 7 will reduce to 3. 21 and 3 reduces to 7. So let's distribute. So this is 3 times x plus 2, 21 times 5, and then 7 times x plus 1. So now I have an equation with no denominators. So let's distribute. 3x plus 6 equals 105 minus 7x. Don't forget that minus sign is attached to the 7, so it's minus 7 times 1, which is minus 7. Let's combine like terms. 105 minus 7 is 98. Get the x's to one side. Get the constants to the other side. I'm going to have to move over here, which gives me 10x equals 92. Divide by the coefficient. You get 92 over 10, but we always want to simplify that as far as possible. So this could be simplified down to 46/5. Before I say for sure that is my answer, you want to make sure it's in your domain. Well, the domain said x can be any real number, so it's definitely in my domain. Plus, I want to check it in the original equation. So I'm going to do my check down here. So we have x plus 2, so 46/5 plus 2 over 7 equals 5 minus 46/5 plus 1 over 3. Okay, so I'm going to put all of this into my calculator. I'll put the left side in first. So 46/5 plus 2 divided by 7. And you get, for the left side, 1.6. Let's see if that's equal to the right side. So the right side, I'm going to have 5 minus 46/5 plus 1 divided by 3. And we get 1.6. So it does, in fact, check out. So that means 46/5 is my answer. Part F, we've got quite a few denominators here. The first thing I would always suggest you do is make sure they're all factored. I can see that this guy is not fully factored, so I'm going to want to factor this first. So let's rewrite this in factored form. This guy, I can pull a 2 out in front. When I do that, you'll see that some of the denominators actually look very similar to each other. That's going to help me. If they were all different, then I have a lot of different exclusions from my domain. At this point, we should be able to tell what my domain is. Remember, none of these denominators can equal 0. None of them can equal 0. So what makes this denominator 0? -3. So that means x cannot be -3. What makes this denominator 0? Well, again, -3. What makes this denominator 0? 2. So in this case, I actually have 2 exclusions from my domain. So x can be any real number, anything at all, except it may not be -3 or 2. Okay? So let's go ahead and solve this now. What I'm going to do is I'm going to multiply both sides of this equation by the least common denominator. In this case, the least common denominator, I'd have to multiply by x plus 3. I'd have to multiply by 2. And I'd also have to multiply by x minus 2. So I'm going to multiply all of this times this first fraction, and then also all of that times this side as well. So let's write that all out. So on the left side, I have x plus 3 times 2 times x minus 2 times 3 over x plus 3. On this side, I'll put this guy first. X plus 3 times 2 times x minus 2. It's going to get distributed to both of these terms. So it's going to be times 5 over 2x plus 3. Then that's also getting distributed to this term. So I'll try to fit this in. X plus 3 times 2 times x minus 2 times this fraction, which is 1 over x minus 2. So all I did was take this common denominator and multiply it to the left side, and then I also multiplied it to the right side, but that means distributing it to both fractions, this fraction and distributing it to this fraction. So you'll see x plus 3's will cancel, x plus 3's will cancel, also the 2 will cancel, x minus 2 will cancel. So everything that's left over will have no denominators. So on this side I have 2 x minus 2 times 3 equals x minus 2 times 5 plus x plus 3 times 2 times 1. So let's combine. 2 times 3 is 6. 6 times x minus 2. 5 times x minus 2. 2 times 1 is 2 times x plus 3. Distribute. 6x minus 12 equals 5x minus 10 plus 2x plus 6. Combine like terms. 6x minus 12 equals 7x minus 4. I'm going to subtract the 7x to both sides. So negative x minus 12 equals negative 4. Add the 12 to both sides. So negative x equals 8. Divide by negative 1, and we have x equals negative 8. Now, of course, you want to make sure that's in your domain. So let's go back and check to see if negative 8 is in my domain. Here's my domain. The negative 8 is not excluded from my domain, so that means it is a possible solution, but we always want to check it in the original just to be sure. So let's go ahead and do our check by plugging negative 8 into the original equation. So we have 3 over negative 8 plus 3 equals 5 over 2 times negative 8 plus 6 plus 1 over negative 8 minus 2. Alright, so let's check the left side. The left side here is 3 divided by negative 8 plus 3, and you're going to get negative 0.6. On the right side, we're going to get 5 divided by 2 times negative 8 plus 6, which is negative 0.5. This last equation is 1 divided by negative 8 minus 2, which is negative 0.1. And when I add those two things together, you get negative 0.6. So they do, in fact, check. Last one. On the back side, we'll do it very similar to what we did the last question. First thing we want to do is factor the denominator because it makes it easier to determine what our domain is. So first I'm going to factor. This is the difference of squares. So it's x plus 3, x minus 3. This is also the difference of squares. It's the same factor. X plus 3, x minus 3. Okay, so my domain is anything that makes my denominator 0. So what will make this equal to 0? -3. That will be an exclusion from my domain. What will make this equal to 0? Because we don't want it to be equal to 0. So 3 would make this 0, and 3 would also be another exclusion from the domain. So x cannot be -3 or 3. These are just repetitive, same exclusions. Once we found the domain, then we can go ahead and solve. To solve, we would find the common denominator. I'm going to multiply both sides by the common denominator, which in this case is x plus 3 times x minus 3. Multiply this side by x plus 3 and x minus 3. So you can see when we distribute that into the first part, we have x plus 3, x minus 3, times x over x plus 3, x minus 3. Then distribute it to the second term, plus x plus 3, x minus 3, times 4 over x plus 3 equals. Now on the right side, you're distributing this inside. So x plus 3, x minus 3, times 3 over x plus 3, x minus 3. Then we cancel the denominators. You'll see these cancel. So all that's left over is x plus 4 times x minus 3 equals 3. So to solve this, we use our linear equation steps from the first page. So we'll distribute first, which gives me x plus 4x minus 12 equals 3. Combine like terms. Get constants to one side. Divide out the coefficient. Is this in my domain? Excuse me. Is this answer? Is it in my domain? Well, at the very beginning, we said x cannot be -3 or 3. So it turns out that our answer that we found down here is not in my domain. X cannot be -3 or 3. If I plug 3 into this denominator here, 3 squared minus 9 is 0. It will give you an error message in your calculator, meaning that this is undefined at 3. So 3 actually is not a solution. So since there are no other solutions, this particular equation has no solution at all. Or it's the empty set.